G'day everybody, hope everyone's well. It's been ages since I've made a video, so we're finally seeing progress on the BMW project. It's been a long time coming. I've sort of teased it here and there with a couple of videos, but we're finally going to start getting our teeth properly into this job, which is good. Good for my mind. As you can see, it's sat for so long just collecting dust. Anyone else that does projects would know that it's sort of depressing when you're not getting any progress. Got rid of the four-wheel drive now. Bit sad for that, but bigger and better things. And we're going to start moving forward, which is good. So the scope of this video is going to be how I've made up the engine mounts and the cross member for my engine swap. Now, I'm going to go ahead and assume that pretty much no one else, in fact, there's a chance that I'm the only person in the world that will have done this swap. We'll be putting a 3RZ in their BMW E39. Despite this, I'm going to try and make this video as information dense as I possibly can. Because this is such a specific project that I'm running, I'm going to try and put the information in this video as broad as I can, so that if anyone watching this is doing a project similar to this, but it being an engine swap on a different car with a different engine, the information in this video is still going to be relevant for you, and it's going to be interesting as well. So we're going to try and do that. As you'd imagine, engine mounts are a very important part in the puzzle that is a vehicle. This is because they are the sole thing that transfers or absorbs all of the vibrations and the torque created by the engine and distributes it into the chassis or the body of the car. We all know the famous saying by Dom Toretto,
"So much torque, the chassis twisted coming off the line."
And this is because an engine that is creating power needs to transfer, or it needs to react off a surface while it puts this torque to work through the drivetrain and moves the car forward. I'm sure all of you have seen videos of drag cars. You can visibly see the twist or the torsion being transferred into the body as the engine accelerates. And it's pretty obvious. If an engine makes 500 Newton meters of torque, that's different to 500 Newton meters of torque on a torque wrench. 500 Newton meters of torque from an engine is constantly applied. If you imagine how much force it takes you to create 500 Newton meters with a bar, and you imagine that continuously non-stop, that's a lot of usable power. So I decided that the best way to start with my build was to make the transmission cross member first. The engine is usually mounted into the body at 3 points. There's what's called a cross member or a transmission mount, which is located on the transmission at the back towards the shifter. And then there's usually 2 points that the engine block is mounted to the body. In this case, which is a longitudinal rear-wheel drive setup of the engine, it's going to be a left hand and a right hand on the engine block. Whereas if you had a front-wheel drive application engine, you'd have what's called an east-west or a transverse setup. You'd have 2 engine mounts, usually either side of the engine block, one being the harmonic balancer side, and then one usually off the gearbox that's bolted to the engine, but there will also usually be 3 points of mounting on a transverse engine as well. First things first, you're going to see me absolutely struggling on a brick driveway. If you ever plan on working on a car, I highly suggest you don't have bricks, because the wheels from my engine crane just get stuck and become an absolute nightmare. So as far as getting the engine mounted into position, it is a bit better if you have someone to help you, but it is doable solo. Best part about a BMW is the fact that the whole radiator support can be unbolted. It makes things so much easier as far as getting an engine in and out. If any of you remember my Nissan Patrol, getting the engine up and over the radiator support, I had to actually take the wheels off and lower it down all the way onto bricks, because there was a four-wheel drive and it was lifted and my engine crane wouldn't give me enough height. So before we do any positioning of the engine and start making any mounts, we need to understand something called pinion angle. I'm only going to go over this briefly. There'll be more videos if you need more information, but the essence of this is that the angle that the drive shaft sits at, where the yoke is at the back of the gearbox, as well as where the uni joint is that bolts up to the differential, need to be equal, or they need to be a parallel angle. The reason for this is uni joints, when they are bent at a certain angle, they will change the rotation from an even constant to ellipse sort of shape. Because of this, if the angles of the yokes aren't equal, you will get excessive vibrations through the drivetrain and you will wear out components faster than normal, which isn't good. As well as this, if you have angles greater than 3 degrees, this isn't good because it's going to put excessive strain on the uni-joint itself. And if you have angles less than half a degree, the uni-joint isn't going to move around enough to distribute grease correctly and it's going to wear out faster. So, rule of thumb, more than half a degree, less than 3 degrees, and equal between the back of the gearbox and the differential. But we're going to go over this later when I line up mine. So now that we understand this, we can decide how we're going to mount and position the engine once it's in the car. So, as I have a machinist background, we're going to talk about the positioning of the engine using XYZ ABC axes. So the Z-axis in this case is going to be the spindle axis of the output shaft of the gearbox. And then what we've got is we've got the X and the Y position. So the Y position is how high it's going to sit in the engine bay. The X position is going to be it in relation to the center line of the car. Usually the engine is centered correctly. I've done this in my case. Next we've got the A and the B axis. The B axis usually shouldn't be changed at all, it should be directly 0. The A axis is what's going to be critical based on the pinion angles, so that's the axis we're going to have to fiddle with. Next we've got the C axis, which is what you'd call the engine slant. So this is going to be dependent on the engine's design. The 3RZ, if you look at it completely front on, this engine has a 5-degree slant. This is designed into it, meaning that the oiling system and the oil pickup tube is going to need to be horizontal while the engine block is on a 5-degree slant. The oil pan on the 3RZ itself has a flat bottom, so you can use that to line yourself up with the engine being how it should be mounted. It's not too critical in these regards. I've spoken to someone before who mounted an engine that was offset on both the B and the C axis, as well as the Z axis from the center line. He did this deliberately because the engine needed to clear the steering box that was designed into the car. Your main factors that are critical when deciding where to mount the engine up, there will be 3 of them. The first one will be if you're running a carbureted engine, the carburetor itself must be level in order for the floats and everything to work correctly. The second one will be the oiling system. The oiling system needs to be correctly positioned so that the oil pickup tube has sufficient oil. And then the last critical factor is what we discussed before, the pinion angle based on the output shaft of the transmission or gearbox. So if we understand all of that, we can get busy mocking the engine up in the engine bay for the first time. You have to get the engine set up exactly how you want it. So this is just a case of fiddling around, either using little bits of wood or a jack under the transmission and just positioning it into the right position, into the right angle that you want it sitting when you make the mount solid. It's a lot easier to do this with a second person, as I said, but you can do it with one person, it's fine. It's just there's a lot of going up and down, moving back and forward and chasing around. So as you can see here, this is how I wanted my 3RZ. I'm pretty happy with how it looks in the engine bay. Because it's a shorter 4-cylinder compared to the BMW 6-cylinder, it does give me a lot of room to play with. However, we're going to have to do something about the pollen filter air rams. As you can see, they're the big round holes through the firewall that I've got plastic bags jammed in. We're going to look at this down the track, but in the meantime we're going to get the engine mounted up and go from there. So the first thing that became apparent once the engine was mocked up in the car was that the gearbox was going to need a shifter extension. This will be the topic of the next video I produce. First thing I looked at was if the OEM BMW transmission mount was going to be usable with the Toyota gearbox. It wasn't going to be, unfortunately. I decided that the mount on the original Toyota gearbox was going to be a better thing to use. This means, you know, in the future it's going to be easy to replace, cheap to replace, and just sort of work better with the project. So I started taking a whole bunch of measurements. I needed as many as I could so that I wouldn't have to keep running out from my computer to the car to take another measurement. What I did then was I found out the original bolt hole measurements for the BMW engine brace. I used these and I measured these with the digital readout on the milling machine at work. Once I had all of the measurements, I was able to draw up a mount bracket that would work for adapting the BMW's bolt holes to the Toyota gearbox's transmission mount. So once I'd taken most of my measurements and I was pretty happy with things, I could then decide what material to use. So based on what my measurements were and what was going to work best for me, I decided a 100mm flat bar that was 6mm thick would do the best job. It's probably a little bit overkill, but you know, it's always better to have more strength than less strength, especially when you're doing a project like this. It's not like I have CAD software that's going to model torsion and model stresses. I'm just doing this based off assumptions. So, with all of the background information out of the way, all the measurements taken and all of the drawings made up, we're ready to get our hands dirty and start getting practical. So, as I mentioned before, it may be a little bit overkill having 6mm thick flat bar for making the mounts up. This isn't that much of an issue, you know, I'm not aiming for the lightest weight possible car. This is just meant to be as sturdy as I can make it, so that the chance of it cracking or getting bent or damaged when I'm doing certain things with it in the future, potentially drifting and clutch kicking, it's just safer in my opinion to over-engineer it now. So all of the pieces that I cut with the grinder I just eyeballed and measured, just as you can see there. When I finally got the pieces cut, I machined all of the bolt holes out on the mill at work so that I had a digital readout to get everything perfect, and then I lined everything up and tacked it into place. I didn't film it because I was a bit pressed for time that day, but as you can see, it came out fairly well. I mounted it in the car. You can see I made some little PTFE pucks that took up the distance for the different heights of the mounting surfaces. After that, I decided it would be good to make some gussets and reinforce this whole piece because it did seem to me kind of flimsy. Best course of action, if you think something's not going to be perfect for the job, make it perfect. Don't go off assumption and assume it's going to be alright. So there's a little bit of welding here and there. I'm no expert welder. I'm sure all of you might start laughing at my welds, but they're going to work, you know. I put enough heat into it where I was getting decent penetration. I can't lay dimes for days, but I'll definitely lay dimes good enough for what the job needs here. So I somehow didn't actually film it with my good camera, but this is the transmission mount all finished up. Looks pretty good, looks pretty sturdy, and before I fitted it into the car, I did hit it with a coat of paint so that it wouldn't rust. Keep in mind that because this is mild steel, it is going to be subject to corrosion. So that's something I'm going to have to consider. After X amount of kilometers, I might want to look at it. If it's getting all road rashed from stones and stuff getting flung at it, I may have to consider taking it off and repainting it periodically. So with the mount all installed, you can see that the transmission has now been lined up perfectly straight down the Z-axis of the car. Again, as I stated before, you could have it a little bit off to the side if you wanted to, but I needed it perfectly straight because the gearbox is quite large in comparison to the BMW one. Keep in mind that the R150 is designed for a pickup truck. It's designed for commercial use. It is going to be a bit larger than, you know, a gearbox designed for the BMW, but that's probably going to come with a fair bit more strength. Now, I'm sure a lot of people are asking the question to themselves, why didn't I run a BMW gearbox? Well, there's two reasons for that. One, this R150 is one of the R series of the Toyota gearboxes. This gearbox was used behind the 1JZ as well as the 1UZ previously, so this means down the track I can just get a bell housing which will adapt these engines to this gearbox. I'll probably have to fiddle around with the mounts, but the mount does have holes in it so that you can change its position forward or back. So that's just a long-term plan with it. There are some BMW boxes that I think are a bit stronger than this, but this will be plenty for what I want at the moment. So that's enough for the transmission mount. We're going to now look at how I did my engine mounts up. So you've got two options with engine mounts. You can either make them solid or give them a rubber bushing or a rubber mount. Ideally, always use a rubber mount. These will absorb the vibrations from the engine, and this makes less chance of welds and stuff being cracked. So I ended up using scaff tube. That's just because I had a bunch laying around. It's also easy to use because I had a bunch of this cardboard tube the exact same size, which I used to mock up the engine mounts. Scaff tube itself, I don't know what its like load rating is, but my thinking behind that is if it can support a human being's life, it can support an engine. So you can see me here lining up the engine to dead center. I used a vernier for exact measurements, but a tape measure would be fine. Within a millimeter for side to side, we'll get it pretty much dead center. So if you can see here, I'm starting to cut up the cardboard. I'm going to use the OEM BMW engine mount. So this is a combination rubber with oil inside it to absorb the vibrations of the engine. I then used a hole saw the right size, same size as the tube, and I used this to notch out the cardboard tube in the right direction. As I said, this is a really easy way to get mounts mocked up or anything mocked up. You can do this in the middle of the night as well. You know, neighbours aren't going to get mad at you using the angle grinder and welding and stuff. It's fairly low noise. As far as using the scaff tube, it's good because it's completely round. It's like a hollow bar. This is beneficial because there's no corners for force to get focused to. It evenly distributes force all the way through it. This is the design I had in my head for the engine mount. I'd use sort of two tubes. The bolt for the engine mount would run down the center of the one piece of tube, and the notched second piece would be welded up straight to the engine mount that was bolted to the E39 originally. This should be strong enough, but I did decide to add a few more supports, which you'll see. Now let me just touch on how you've got to be careful when you're cutting and you're grinding scaff tube. This is galvanized steel. Galvanized steel has a layer of zinc, and this is potentially harmful to your health. There is, I think, known problems and known symptoms when you breathe in or you absorb too much of this zinc into your body. So if you're going to weld it or you're going to grind it, it's good to use a face mask just to stop any of the particulate getting into your lungs. So with both the engine mounts mocked up out of cardboard, I'll show you the benefit to using a round tube or a hollow tube. You can use paper to mark out the template, and then you can translate the paper template onto the piece of metal and then notch it the exact same as the cardboard. So just wrap a piece of paper around your cut tube out of cardboard, tape it up, and then cut that down to the exact size of your cardboard cutout. Once that's done, you can just slide out the cardboard, and then you can slide in your scaff tube. And all you got to do is use a marker and mark out on the tube where the paper is cut. And then once you cut the tube where the marks are, you'll have an exact replica of your cardboard cutout. the mount's all finalised, you can hit everything with a coat of paint to make sure it looks good and it's going to last as long as possible before corrosion starts happening. Everything's all done, everything's all finalised, so this is the end result, which I have to say I'm pretty happy with.